Welcome to ECE 341 Random Processes. This is a course that covers basically an introduction to statistics. Now in this video, I'm going to go over the course, kind of an overview, how the course runs. Now starting out, Random Processes is a course that's on Bison Academy. Bison Academy is the semi-official website for the Electrical Computer Engineering Department at NDSU. It's got quite a few different courses. One of those is Random Processes. And what this does is if you ever need to go back and review, such as I forget Circuits 1, well, everything's here available on Bison Academy. The lectures, the videos, handouts, homeworks, labs, stuff like that. Random Processes is also on Bison Academy. If you click on the link, this is where all the information is. It contains all the lectures, both in portrait and landscape format. On the videos, I use landscape format, shows up a little bit better. Some people prefer portrait format, a little bit easier to print out. Basically what the landscape format is, I took out all the verbs, makes a pretty presentation that I can present it in the lectures. If you want to have all the verbs and adjectives put back in, that's the portrait format. All the lectures have been recorded and posted on YouTube. So here's the recorded lectures. If you want to invite your friends and neighbors over and binge watch all the videos, there's a YouTube playlist that goes through all the different videos as well. There's sample code. Throughout this semester, we'll be doing sample code in MATLAB. So you can either copy and paste from the lecture notes, or conveniently, this is the sample code right here. That's in a text format, so you can copy and paste into MATLAB, along with the various homework sets and solutions. Now the solutions will be posted throughout the semester. I'll post the solutions after the homework is due. If you want to go back and see how did you do the problem previously, well, the last couple times the course is run, the homework sets, solutions, and YouTube videos where we go over that are all posted as well. That's kind of a nice resource for students. So this is kind of where the textbook, lectures, videos, homework, solutions are all posted. What I'm going to do in this video is just kind of give you an overview of the course and how the course runs. So starting out, Random Processes is about, of course, Random Processes. This is basically an introduction to statistics. Now, if you're an electrical engineer, computer engineer, this is the only course you're going to take on statistics. So we did a little bit of background on that. The real point of the course is towards the end of the semester, we get into data analysis. When you go into lab and collect data, that's a random process. Every time I run an experiment, I'll get a different answer. How you analyze data that's random, it's different every time you run it. That's what statistics is all about, data analysis. But to get there, we need a little bit of background. That's the first part of the course, basically a background on statistics. Now, some things are random processes, some things are not. A random process is a repeatable event where the outcome is different every time. Now, some things are not random processes. If I ask a question like, can I write a program to play poker? Well, that's not really a random process. That's either yes or no. If I ask, did it rain last April? That's something about the past. I can look it up. I can do a Google search and find out, did it rain in Fargo last April? The answer is yes or no. If I ask about the Packers beating the Vikings, Vikings beating the Packers, that's not a repeatable event. And the Vikings will only play the Packers one time. Probability is really defined as a repeatable event, like the opening game for the Vikings. I can't have that game being played 1,000 times. It only happens one time. So technically, those are not random processes. What a random process is would be something like asking, how long does it take me to write a program to play poker? You know, that'll vary. Every time I write the program, I get a different answer. That's a random process. If I ask about how much will it rain this coming April, again, it varies every year. The future, there's many, many futures. I'm going to get different answers every year, every time it happens. That's a random process. So this course is all about random processes. The reason this is a required course for electrical engineers, computer engineers, software engineers at NDSU is data analysis. Now, every time you go into lab, build a circuit, every time you write a program, want to test it, I'm going to get a different answer, different amount of time to write the program, different voltages and currents every time I build the circuit. There's tolerance on the components. Every time I test my circuit, I'm going to get a different answer. And random processes is a tool that lets you analyze such systems. But before we get into data analysis, we need a little bit of background on statistics. That's the first part of the course. So the way the course starts is we're going to look at a thing called Monte Carlo simulations, enumeration, and then combinatorics. Monte Carlo simulations look at if I could write a program to play a game one time, then I can throw it in a for loop and play the game 1,000,000 times. If I count how many times the event happens in 1,000,000 trials, that's roughly the probability. That kind of uses the definition of statistics, probability. Probability is as the number of trials goes to infinity, what percentage of the time do I get a success? Well, in MATLAB, I can play a game 1,000,000 times. It's not quite infinity, but you kind of get the idea. For a large number of games, what's the number of successes? That's a way to estimate the probability. It's not exact, because every time I run the program, I get a different answer. An exact way of doing it is enumeration. With enumeration, I list out all possibilities. In poker, there's only 2.5 million different ways to deal out hands. I can count. How many of those hands are three of a kind? How many of those hands are full house? That'll give me the probability exactly. Now, the problem with enumeration is you have to go through every possibility. Sometimes that's practical. If I want to roll 2 6-sided dice, there's only 12 possibilities. I can do that. If I look at some hands like bridge, where I deal out 13 cards from a deck, there's just too many to list out. In that case, I can use combinatorics. Combinatorics is a way to calculate how many different hands are three of a kind, how many different hands are full house. I should get the exact same answer that I got with enumeration, but the advantage is with combinatorics, I don't have to grind through every possibility. I can calculate all the possibilities. The next section we'll look at are discrete probabilities. Now, some events only have discrete outcomes, like if I flip a coin. It's either heads or tails. If I flip n coins, I either get 2 heads, 3 heads, 4 heads. That's a binomial distribution. A uniform distribution is like rolling a die. When I roll a 6-sided die, I only get the answers or the numbers 1 through 6. If I roll 6 6-sided dice, I get various combinations. That's uniform distribution. A geometric distribution is I roll a die until I get a 1. I play a game until I win. A Pascal distribution is I roll a die until I get n ones, like roll until I get 3 ones. Now, those are all types of discrete distributions, and we'll look at the mathematics for analyzing discrete probabilities, along with the z-transform. Now, in statistics, they normally call the z-transform the moment generating function. In electrical computer engineering, we call that a z-transform. Z-transforms are used in many different courses, like signals and systems, control systems, digital control. It's also used in statistics. Anytime I have discrete events, like the roll on a die is a discrete number, 1, 2, 3, 4, 5, 6. The mathematics that describe discrete events is the same across signals and systems, control systems, digital control. We call it a z-transform. In statistics, they call it a moment generating function. I'm going to call it a z-transform just because it ties into other courses. It's the same thing. Next topic we'll look at are continuous distributions. Now, some events can take on any value. For example, if I have a resistor. If I have a 5% tolerance resistor, it could take on any value between minus 5% and plus 5% for like a 1K resistor. One way to model that is the uniform distribution. It takes on any value over that range. It doesn't have to be integer values. It could be 996.2835 ohms. That's the uniform distribution. An exponential distribution would be, for example, the time until a customer arrives. A gamma distribution is the time until our customers arrive. A Weibull distribution is a continuous distribution that doesn't have any theoretical basis, but it can curve fit a lot of distributions. So sometimes in research, if I don't know what the distribution is, I can assume a Weibull distribution and it'll curve fit just about anything. And then finally, we'll look at the normal distribution. The normal distribution is what you're used to. It's the standard bell-shaped curve that you've seen over and over again. Well, for all these distributions, we'll look at the mathematics for analyzing continuous distributions, along with this moment-generating function, which in this case is the Laplace transform. Finally, at the end of the semester, we'll look at data analysis. With data analysis, I collect data and I want to analyze it, and there's a couple ways to do that. There's actually thousands of ways to analyze data. In this class, we'll look at 3 different tests: a t-test, chi-square test, and f-test, or analysis of variance. A t-test is a test of a mean. We'll start with looking at a single population. With a single population, I can do things like, what is the probability of rolling a 1 on a 6-sided die? What is the probability of getting dealt a full house? There I can collect data, and then from that data, analyze what's the probability. Look at a t-test with 2 populations. If I have 2 populations, A and B, I can say which one has the higher mean. What's the probability that 2 people playing Hungry Hungry Hippo, A will win by 5 points or more? That's a t-test with 2 populations. We'll look at a chi-square test. A chi-square test is a test of a distribution. With it, I can analyze, is a die fair or is it loaded? I can analyze, does X have a uniform distribution? Like for resistors, if I say they're plus or minus 5%, I can collect data and analyze, does that match with a uniform distribution? And finally, we'll do analysis of variance. That looks at an f-test. An f-test is a test of a variance. Is the variance of one population more than another? Analysis of variance is looking at, do n populations have the same mean? There's thousands of other tests, but at that point we'll run out of time. Those are 3 of the main tests you'll ever use. The t-test is probably the most important. Most of the tests that you'll ever run are t-tests. So that's kind of where the course is heading. And all that is on Bison Academy. Kind of go through the semester and see the different topics that we're covering. In terms of course information, my name's Jake Lauer. Lectures are, our scheduled lab times, scheduled days. During the summer, it's Monday through Friday at noon. The recitation is, again, on the syllabus. Typically in the summers, it's between 7 p.m. and 8 p.m. on Zoom. The bulletin description. This course covers discrete and continuous probability functions, hypothesis testing, with a prereq of Calc 2. If you've had a couple courses in electrical engineering, that would help. I do a lot of examples from electrical engineering, since this is a course for electrical computer engineering. The objective is by the end of the semester, you should be able to compute probabilities using enumeration, combinatorics. You should be able to compute probabilities using discrete probability events. You should be able to compute probabilities for continuous probability events. And, here's the important part, be able to analyze data using various statistical techniques, specifically t-test, chi-square test, and f-test. In terms of the way this course is offered, this course is offered using the full HyFlex model. What that means is each class is offered in person, live streamed, or online. In person, you're more than welcome to show up, attend class in person. I don't really care if you've signed up in person, online. There's plenty of space. If you want, you can stream the class online. All classes are live streamed on Zoom. There'll be a Zoom link sent out at the start of the semester for how to hop on and join the class remotely. Plus, all classes have been recorded and posted on YouTube. You're more than welcome to watch the YouTube video as well. And it really doesn't matter to me how you signed up for the class. You're welcome to take it any way you want. You can watch the videos, live stream, attend in person. I don't care. It's kind of your choice. And you're more than welcome to change on a daily basis. Makes no difference to me. Now, that being said, in-person is better than online. Course evaluations for people that take my classes in person are higher than they are for online people. Again, not surprisingly, I've been teaching in person for 35 years. I'm better in person than online. The grades for in-person attendance are higher than online attendance. That's just kind of the way it is. It's your choice, though. If online works better for you, you're more than welcome to take the class online. If in-person works better for you, you're more than welcome to take the class in person. As long as you get the homeworks done, as long as you take the tests, I don't really care. In terms of the resources you need to take this class, the biggest one is MATLAB. Now, MATLAB is free for all ECE students. Up at the top on Bison Academy, there will be a link, which I haven't put up there yet. There will be a link shortly. I try to get to MATLAB, and this is through NDSU. As long as you're an NDSU student, you can use MATLAB for free. NDSU pays for the site license for all its students. Again, as long as you're a student, you can use MATLAB. MATLAB is required, and the way MATLAB is used is really just a programmable calculator. It works really well for this course as well as many other courses. So most of the homework sets will be having you write programs in MATLAB, doing testing in MATLAB. So you need access to MATLAB. You also need internet access if you're in person, you don't need internet access. Otherwise, you do. All the lectures, recorded lectures, are posted on Bison Academy. The syllabus is on Bison Academy. Homework sets are posted on Bison Academy. Basically, you need access to the internet to get to Bison Academy. So here's 341 random processes. That's on the web. The textbook for the course is free. Bison Academy has the online textbook. It's an open educational resource, free for all students to use. It's actually free and available for everyone. It's not copyrighted. All the information is available many different places. It's been kind of summarized. The textbook's written by me. So it's available for anyone to use. All lectures have been recorded and posted on YouTube, linked on Bison Academy. And also, Bison Academy includes other classes. If you forget, how do I do circuit analysis? How do I use the transistor? Well, you can just go on Bison Academy and click on it. All that information is available. Part of the reason for that is in electrical computer engineering, it's a building process. You're not supposed to forget everything that you learned at the end of the semester. You need to remember it because stuff that you learn in Circuits 1 is used in Circuits 2. Stuff you use in electronics is used in embedded systems. Stuff you use in embedded systems is used in senior design. And this is kind of a building process. We hope that you remember what you did in previous courses. And if you forget, this is a convenient way to remember, get a refresher. How do I use the transistor as a switch or stuff like that? So that's one of the main resources is Bison Academy. If you want other resources, there's plenty of good books on statistics out there. I would just go on to Amazon and look for a used book. Yates has a very good book on statistics. DeGroot has a very good one. Bulmer. These are all terrific references. The version doesn't matter. I would buy a used version. That's the cheapest one you can find. Statistics doesn't change over the time, at least not a whole lot. So if you buy a book that's 5 years old, it's just fine for this course. What the publishers do is they change the homework problems in the back of the book. Oh, well, I don't use the publisher's homework problems because I like to post solutions. For example, this semester, here's the homework problem, there's the solution, recorded solution. The reason I like posting solutions is I think it helps in learning the material. You go over the material on the lecture, you do a homework set, then we go over the homework, and I show you how I would solve it, both in a PDF format and a YouTube video. I can't do that with published textbooks because that's a copyright violation. So all the problems in this class are unique to this class, problems I made up. That makes it legal for me to post solutions. So again, if you have an old version and the homework problems are different, doesn't matter. We don't use the homework problems from the textbooks. In terms of homework sets, the homework sets are posted on Bison Academy. If you go under old homework sets, the previous semester's homework sets and solutions are also posted. Now, this is a place to go if you need help with the homework set. I forget how to do it. I don't really know how to approach it. You can look at what the problems were from previous semesters and how those were approached. Now, the problems change every semester, so don't just copy and paste, saying this is the answer from summer 2024, copy and paste. It'll be wrong, because I changed the problems. But the approach will be similar. I'm using t-test, chi-square test, z-transforms, Laplace transforms, and so on. The approach will be similar, use of MATLAB will be similar, but the problems are different. In terms of the homework sets are due 8 a.m. the following day, at least in the summer. That's because the way the summer works is every day we have a new topic, homework is set. We'll go over that homework the following class, and then the next topic. So the homework is due 8 a.m. the day that it needs to be submitted, 8 a.m. on the day that we're going to go over it. Again, in the summer, what that does is summer classes are at noon. That gives me between 8 a.m. and noon to grade the homework sets, post the solutions, and then cover the next day. If there's classes during the semester, it'll be slightly different during fall and spring, but that's how summer runs. Once the solutions are posted, the homework's not sets aren't accepted because it kind of takes the challenge out of doing the homework if the solutions have been already posted. As far as submitting the homework, you can submit them as a hard copy. You can submit them on Blackboard by uploading PDF or Word document, or you can email me. Now, for electronic submissions, as long as I can read it, that's fine with me. What works really well is MS Word, PDF files, or JPEG images. If you write them out on paper, just take a picture and upload the JPEG image. MS Word works really well. I can just take my answers for MATLAB, just copy and paste the MATLAB code into the Word document. If there's a figure in MATLAB, just use the snipping tool, copy and paste the image into your Word document. So Word documents work really well. I can read Word documents and see what you did. Again, hand copies are fine too. Just take an image, upload the JPEG image. As long as I can read it, that's fine. Just don't encrypt it as a zip file. Makes it hard for me to open. In terms of the way the course is graded, the course has 3 tests and a homework set. Each has equal weighting. Grades are rounded to the nearest 1 point, with the grade being a straight scale, 90% A, 80% B, 70% C. I grade straight scale because if you learn the material, you're in a study group, everybody learns the material, I'm happy to give out all A's. On the homework, you're more than welcome to work together, teach each other how to do the problems. Testing, however, is individual effort. Please do not work together on tests. I get kind of upset if people do work together on tests. The lectures vary each semester. In the summer, lectures are at noon, Monday through Friday. All lectures are live streamed on Zoom. They're also recorded and posted on YouTube. Note, however, you're welcome to attend however you like. The lectures are required. However, you're welcome to attend in person. You're welcome to live stream the lectures. You're welcome to watch the YouTube videos. Makes no difference to me. As long as you can do the homework, pass the class, pass the tests, that's fine with me. Office hours during the summer are between 7 and 8 p.m. on Zoom. That way, for the online students, if you need to get a hold of me, typically online students are working during the day, so the evenings are when you can get a hold of me. You can also email me if you have questions. And legal stuff. Again, attendance is required. How you attend is up to you. If you have special needs, let me know. We will accommodate you. In terms of academic honesty, especially on tests, please do your own work. The point behind academic honesty is that when you graduate, you're going to be designing defibrillators, pacemakers, flight controllers, things like that. That's what our graduates do. If you somehow figure out how to get through the courses without learning anything, please don't. Again, you're going to use this material when you get to industry. If you manage to graduate without learning anything, your boss will pick up on that really quick when you graduate and you'll lose your job. So it's kind of not in your interest to do that. Learn the material while you're here at NDSU. That way, when you graduate, go to industry, you'll know what you're doing. So again, if you can figure out a way how to get through the classes without learning anything, please don't do that. The whole point of the class is to learn how to analyze data, so when you graduate, go to industry, I'll know how to analyze data. It's a whole lot easier to learn it while you're here at NDSU than have to go to industry and have to learn the material while you're on your job and your job's at stake. Also, if you're a veteran, let us know. We'll accommodate you. So that's kind of an overview of 341. It's a course I really enjoy. It's a course on statistics. I really enjoy statistics. Statistics is really powerful. It really frees up what you can do. So this is a course that I hope you'll enjoy. I enjoy it. We'll continue on with the following videos, going over the various topics in the course. So that's lecture number 1 for ECE 341, going over the syllabus and the content of random processes.